Hello students, welcome back to class. Today we will do exercise 6.2 from question number 7 to 10. In last video we have discussed 1 to 7 question, but in 7th question my voice was not audible. That's why 7th we will repeat today. Using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. Recall that you have studied in class 9th. Let us see this question. What is 6.1 theorem? 6.1 theorem is basic proportionality theorem, BPT theorem. What is this basic proportionality theorem? A line drawn through the midpoint of two sides of a triangle. If a line is drawn parallel to one side of a triangle, bisecting other two sides at two distant points, then other two sides are divided in the same ratio. This is 6.1 theorem, and this is proof that a line drawn through the midpoint of one side of a triangle parallel to another side bisect the third theorem. In 9th class, this is converse of midpoint theorem. This is converse of midpoint theorem. Let us start. Consider this A, B, C is a triangle. If a line is drawn through the midpoint of one side of a triangle, let us consider this D is the midpoint of AB. If a line is drawn parallel to this BC, say this point is E, it will bisect this third side. That is, we have to prove AE is equals to CE. Okay, what is given? To prove this, you will write given D is midpoint of AB and this DE is parallel to BC. If this DE is parallel to BC, then I can use theorem 6.1. Then in triangle ABC, if this DE is parallel to BC, then I can write corresponding sides ratio will be equal. AD by BD equals to AE by EC. This is by BPT theorem. What is BPT theorem? Basic proportionality theorem. Say equation number 1. Now, second thing, this we have to prove this E is the midpoint of AC and D is midpoint of this AB, as D is midpoint of AB. So what I can write? AD equals to DB. AD equals to DB. Now see, this AD by DB equals to 1. This I can write equals to 1. Say this is equation number 2. Now see, from 1 and 2, this AD by DB is 1 using equation 2 in equation number 1. This AD by DB is 1 equals to AE by EC. Using cross multiplication, EC equals to AE. This EC is equals to AE. EC is equals to AE. If this AE is equals to EC, then this proves that E is midpoint of AC. This E is midpoint of AC. Question number 7 is completed. Question number 8. Using theorem 6.2. Theorem 6.2 is converse of BPT theorem. Prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. Recall that you have done it in class 9. This was midpoint theorem in class 9. And 6.2 is converse of midpoint theorem. Let us draw a triangle A, B, C. If a line joining the midpoints of any two sides of a triangle. Consider this D and E. D is midpoint of AB and E is midpoint of AC. Prove that line joining the midpoints of any two sides of a triangle is parallel to third side. What is to prove? First of all, write what is given. Given this D and E are midpoints of AB and AC. AB and AC respectively. What is to prove? To prove is this DE is parallel to BC. This DE is parallel to BC. Now see, as D is midpoint of AB, prove. As D is midpoint of AB, then I can write AD by AD equals to DB. If it is midpoint, then this AD distance is equals to DB. Length of AD will be equals to DB. From there, AD by DB equals to 1. So equation number 1. Now, similarly, we know this E is the midpoint of AC. E is midpoint of AC. Then AE is equals to CE. AE will be equals to this CE. Now, AE by CE equals to 1. So equation number 2. Now see, from 1 and 2. From 1 and 2, both equation contain right hand side as 1. So we can equate these two equations. We can write from 1 and 2. This AD by DB equals to AE by EC or CE. AD by DB, AE by EC. Now, in triangle ABC, ratio of corresponding sides are equal, then these lines will be parallel. Means this DE will be parallel to BC. Why? By converse of midpoint theorem, converse of BPT theorem. Now, from there, we can say if AD by DB is equals to AE by EC, then this DE is parallel to BC by theorem 6.2, or what is theorem 6.2? It is converse of BPT. Converse of BPT. This DE is parallel to BC. This only we have to prove. Let us revise this question again. Using 6.2 theorem. 6.2 theorem is converse of BPT. Prove that line joining the midpoint of any two sides of a triangle is parallel to the third side. Now, this is midpoint theorem. In 9th class, we have done this theorem as a midpoint theorem. Now, midpoint theorem we are proving with the help of converse of BPT. In this, what is given? This D and E are the midpoints of AB and AC respectively. What is to prove? This D is parallel to BC. Now, this D is midpoint of AB, so I can write this AD is equals to DB. And now AD by DB ratio is equals to 1. Say this is equation number 1. Similarly, this E is midpoint of AC. Now AE distance is equals to this EC. From there, AE by CE is equals to 1. So equation number 2. By comparing 1 and 2, we will get AD by DB equals to AE by EC. In this triangle, if you will see, AD by DB and AE by EC, then this DE will be parallel to BC. Question number 8 completed. This is by converse of BPT. If these corresponding sides are in the same ratio, then this DE will be parallel to BC. This is by converse of BPT. Question number 9. ABCD is a trapezium in which AB is parallel to DC. Let us draw one trapezium. A, B, C, D is a trapezium. AB is parallel to this DC and its diagonal intersect each other at point O. Draw its diagonal. These are two diagonal AC and DB. These two diagonals are intersecting each other at point O. So this point is O. Show that this OA by OB, OA by OB and OC by OD. This we have to prove. What is given? Given a trapezium ABCD, AB in which AB is parallel to DC. What is to prove? To prove is AO by BO equals to CO by DO. This is to prove. In this question, let us do some construction. Construction is draw a line through this O point, say this is OE parallel to AB. What is construction? Draw a line through O parallel to AB, as this line is OE is parallel to AB and AB is parallel to DC. This implies this OE will be parallel to DC. Means this OE is also parallel to DC, AB is parallel to DC, and we have drawn this OE parallel to AB, then this OE will be parallel to DC also. Now proof. In triangle, let us consider triangle ADC. 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 Okay. This OE is parallel to the CD. OE is parallel to the side CD. Then I can write by BPT theorem. AE by ED equals to AO by this OC. This is by BPT theorem. In this triangle ADC, this OE is parallel to this DC. Okay, OE is parallel to CD. ADC. Yes. Now by BPT I can write AE by this ED is equals to OA by OC. So equation number 1. Now equation number 2. How we can find out equation number 2? Similarly, in triangle ADB, ADB triangle, this OE is parallel to AB. Then I can write AE by this ED equals to AE by ED, then OB by OD. OB by OD. By BPT theorem. By BPT. This OE is parallel to AB, then AE by ED ratio is equals to OB by OD. Corresponding sides ratio will be equal. This is by BPT theorem. So equation number 2. From 1 and 2, you will see AE by ED and AE by ED. So we can write this OA by OC from 1 and 2. This OA by OC, their left hand sides are equal, so their right hand sides will be equal. OA by OC is equals to OB by OD. OB by OD. Let us see what was our to prove. To prove was AO by this OB. So using cross multiplication, this OA by OB equals to OC by OD. This is proved. Let us revise again. This ABCD was a trapezium. In this trapezium, AB is parallel to CD. By construction, this OE is parallel to AB, but this AB is parallel to CD. So this OE will be parallel to CD. You will work in triangle ADB. This OE is parallel to AB, so you will write corresponding sides ratio equal. This is by BPT theorem. If this OE is parallel to AB, then corresponding sides ratio will be equal. And similarly, in triangle ADB, this OE is parallel to the CD side, so corresponding sides ratio will be equal. Now, if you will compare equation number 1 and equation number 2, then you will get the ratio OA by OC is equals to OB by OD. But this was to prove, you have to use one more step, you have to simplify. Using cross multiplication, you will take this OB in denominator of OA by OB is equals to OC by OD. Next question. What is next question? Question number 10, last question of this exercise. The diagonals of a quadrilateral ABCD intersect each other at point O. Show that. Draw a trapezium. A, B, C, D. ABCD is a quadrilateral, sorry. The diagonals of a quadrilateral, this ABCD is a quadrilateral, intersect, its diagonal intersect at point O. Show that OA by BO equals to CO by DO. This is given such that this is given. And what is to prove? To prove is this quadrilateral ABCD is a trapezium. This ABCD quadrilateral is a trapezium. Okay. Diagonals of this quadrilateral intersect each other at point O. Now we have to prove, and this ratio is also given to us, OA by OB equals to CO by DO. This ratio we will use. We need to prove this ABCD is a trapezium. How we can prove this ABCD is a trapezium? If I'm able to prove this AB is parallel to CD, one pair of opposite side is parallel, then this quadrilateral ABCD will become a trapezium. Let us start its proof. Before starting proof, some construction we have to do in this. Let us do some construction. Draw, say this OE is parallel to AB, or you can say DC. OE is, draw a line through O parallel to AB. Now see, if this line is parallel to AB, then in triangle, proof, in triangle ADB, OE is parallel to this BA. You can say OE is parallel to BA. Then I can write this AE by AD ratio is equals to OB by OD ratio. OB by OD ratio. By BPT theorem, this OE is parallel to AB, then corresponding sides ratio will be equal. This is by BPT theorem. Now, this AE equals to ED as it is, this ratio OB by OD. What is given to us? I will make use of that. OA by OB equals to CO by DO. Now see, OB by OD, using cross multiplication, I can write this OD by OB equals to CO by OA. Now see, from there, in place of OB by OD, I can write CO by OA. Let us use next page. This AE by ED. AE by ED is equals to, first it was equals to OB by OD. OB by OD. Now AE by ED we can write equals to AE by ED is equals to OB by OD, and from there in place of this OB by OD we can take its reciprocal. This will be OB by OD equals to OA by CO. OA by CO. OA by CO. Let us check out. Okay, again see, in triangle ADB, this OE is parallel to AB, then corresponding sides ratio will be equal. Now see, from there we can write OA by CO. From there, from equation number 2, if you will see, check in figure, AE by ED equals to OA by OC. This is the ratio of corresponding side. Ratio of corresponding sides are equal, then this OE will be parallel to this CD. This OE will be parallel to CD. Again see, this AE by ED is equals to OB by OD. This is by BPT. Now what is given to us, you can make use of that, and after that you will get AE by ED is equals to OA by CO. OA by CO. OA by CO, AE by ED. It means this OE is parallel to CD. OE is parallel to CD. This is by converse of BPT. By converse of BPT, we are able to prove that this OE is parallel to CD, and this OE was parallel to AB, and now we are able to prove OE is parallel to this CD. OE is parallel to CD. Then we can say this AB is parallel to CD. If AB is parallel to CD, then this quadrilateral will become a trapezium. ABCD quadrilateral is a trapezium. Exercise experiment 2 is completed. Thank you.